All right, let's go ahead and get started today. We are now. You voted by an overwhelming majority to have your test on Thursday, this coming Thursday. So we're going to review today for the test. We're going to go over the practice problems that are on Canvas. Now we can go through all of them. So we'll have the test Thursday, and then next Tuesday we're going to go back to chapter 6 and start at chapter 6, and then we'll cover chapter 7, and then we'll jump ahead to chapter 9, and we'll just finish out the rest of the semester. Okay, so the test on Thursday is only over 2 chapters, chapter 5 and chapter 8. Okay, now I want to point out a couple of things. If you go to your Canvas homepage, what you're going to see is information on the second test. So you've got your practice questions. Now it just says chapter 5 and chapter 8, but this is the second test, practice questions. The solutions, these are worked by hand. So this is just went through and did the calculator inputs. That's what I'm going to be doing today. But if you forget something about what we talked about today, you can always go back and look at this, okay? Also, these are just the answers, so just the ABCD part to the multiple choice. You've got your study guide here, and then a chapter 5 formula sheet and chapter 8 formula sheet. These are going to be attached to your test on Thursday, so you can take a look at those. Let's take a look at the study guide real quick. And again, this is going to be pretty straightforward. Even though it's just 2 chapters, they're 2 pretty big chapters. And so, for example, chapter 5 was time value of money. So that's using your financial calculator, calculating future value, present value, single dollar amounts or lump sums, annuities, annuity dues, which is the beginning of period payments, ordinary annuities, which is the end of period payments. And so that's what all of this covers. I mean, just everything in chapter 5 that we talked about. The only part of chapter 5 that you are not responsible for has to do with continuous compounding. Okay, and you'll see a little part on that. And I said it's in terms of end of chapter questions, any of the problems at the end of chapter 5 are good practice problems except for the continuous compounding problems. So that's basically, everything in chapter 5. Chapter 8 was the risk and return chapter. Again, a pretty large chapter. So things like risk, what is the definition of risk? What is return? How do you calculate it? What's a portfolio? What are the different types of risk preferences? What are the 2 types of risk assessment that we talked about in class? Those are the non-technical ways to calculate the risk of an investment, of a single asset. Types of risk measurement and calculation. So we talked about standard deviation and the coefficient of variation. What's their definition? How do you calculate them? You know you're going to see problems associated with this on the test, so it shouldn't be a surprise. Portfolios return, how to calculate that. Again, remember that's just a weighted average, so you simply take the percentage weight of the asset times its expected return, and you just multiply that out, add them all together. That's the weighted average or the portfolio return. The portfolio beta is the same way, just simply the weight times the beta. We talked about correlation, what is positive correlation, what is negative correlation, what is perfect positive correlation, what is perfect negative correlation. The concept of diversification, what does that mean? Also the capital asset pricing model, how do you calculate it, what's the definition of it, how do you use it, etc. Diversifiable versus non-diversifiable risk, know what they mean. Other names for them, so we said diversifiable risk is also known as unsystematic risk. Non-diversifiable risk is also known as systematic risk. Diversifiable risk can be completely done away with. We can diversify it away. Non-diversifiable risk is what we're concerned with managing as investors, and non-diversifiable risk is typically measured by beta in the context of a portfolio. And also, so know what beta is, what it measures, and then we talked about 2 things that will change the security market line. We talked about a change in inflation will cause a parallel shift up or down of the security market line. a change in investor risk aversion will cause a change in the slope of the security market line. If they're more risk averse, the slope increases. If they're less risk averse, the slope decreases. Also, the calculator. Practice with your calculator before the test, please. I've had students call me the night before the test, and I can literally on the phone hear them tearing into their financial calculator package and all the plastic, and they're like, "Dr. Lacewell, can you go over what we did in class on the calculator?" The night before the test. I'm a pretty nice guy, okay? But my answer to you is going to be no. I cannot cover everything that we went over in class, the 4 class periods that we spent on Chapter 5. I can't cover that on the phone in one night. So it's a little bit too late. So practice with your calculator. And that well, sometimes things mess up, okay? And during the test, if you have a question, that's fine. You know, if something doesn't seem to be working right. But practice clearing it out. Practice changing from 1 payment per year to 12 payments per year. Practice from changing to end of period payments to beginning of period payments. I mean, those are just things that you're going to have to be used to doing. And if you kind of, I mean, you can use the search method, which means you've got 4 answers to choose from, and you just kind of start working with your calculator and see if any of the numbers show up. But you've got 90 minutes roughly to take the test, and it's going to take a while to do it, going through all 4 answers to all of the calculations. Now, let me say something about the test. In the chapter, I tend to focus pretty heavily on the calculations, but on the test, it's pretty evenly distributed between definitions and theory type questions and calculations. As a matter of fact, it's probably 40% calculations, maybe 45%, and the remainder definitions and theory type questions. And I tell you this because I don't want you just studying all of one thing. Just like with the first test, I told you, don't just study all calculations, because if you do, you'll do fine on those, but there's over half the test that doesn't involve calculations. Or don't just study the definition. So again, that should kind of help you weigh your study time in terms of how you prepare. Also, the questions, I try to divide them pretty evenly between Chapter 5 and Chapter 8. I think Chapter 5 is probably a little more important, so it may be a little more heavily weighted towards Chapter 5 questions, although it's fairly even on the 2 chapters. It's all multiple choice. It will be 50 questions, again, just like the first test. You will have 90 minutes to take the test. And what else? Any other questions about the test itself?
Are we able to use like a TIA4 when we get the formula for that as well?
You will get a formula sheet on there for the test. And so with the TI-84, what I would suggest is using the finance function to do the calculations, the time value of money calculations. But yes, you can use it though.
Will we get the formulas for what like
the steps?
Yeah.
No. Yeah, no. There will be no for either calculator, the BA2 Plus or the TI's 84, 85, whatever. The calculator steps, I mean, those are things that by the time you get to the test, you really need to know how to work them. Because if you get to the test and you're not prepared, I mean, it's just not going to be a good outcome. All right, so other questions? I do. So officially, they are from, see, I've got a meeting at 10. I think they're officially from 12 to 2 tomorrow, although I'll be in there probably earlier than that, and I know I'll be in there later than that. So, but if you know you're going to come by at a certain time, just shoot me an email and say, hey, I'm going to be here at a certain time, and I'll block off that so that we'll have a few minutes to sit down and talk about the test or whatever it is. All right, other questions before we get into the practice questions on Canvas. Oh, a couple other things before I forget it, and I'll send you this probably via Canvas. And for some of you, the first one may not help too much. Maybe some of my online students might benefit from this. But there is a company in Louisville that is they have an internship. They're looking for somebody for about 20 hours per week, and they really want somebody who is in the Louisville area. Okay, I know some of you might live there and you might go back on weekends and stuff, but I just don't think that would work. Although, when you see it, feel free to contact the company. And for example, if you don't have Friday classes, you might be able to get it worked out. I don't know, but it's primarily for somebody who's located in the Louisville area. Also, one of the banks in town is looking for a teller supervisor. So if any of you have teller experience or know people who have teller experience and they're looking for a job in banking, I'll send that out. It'll have the contact information on there, and you can pass that information along to whoever might need it. All right, now let's work some problems. All right, so here we go. In as large as I can make it and still keep it on the screen. Just some basic questions. Now, let me say this. You've got 33 questions. The first 16 are from chapter 5. The last 17 are from chapter 8, I believe. I would work these questions. I would answer these questions, work the problems. Take a close look at the questions. You may see some of these again this week on Thursday at 12:30. Okay? I can't get much more specific than that, okay? But I would look at these questions very carefully because some of them may enter your life again in the coming week. All right, now, number 1. In future value or present value problems, unless stated otherwise, cash flows are assumed to be or to occur when? At the end of the period. Okay, so the answer is A. We assume, and if it doesn't mention anything about it in the problem, we assume they occur at the end of the period. If you do see the word beginning in the problem, then you're thinking, okay, I need to make some changes here. Especially if it's an annuity, then you need to change to an annuity due. You need to change your calculator to the beginning of period payments. Number 2, the future value interest factor is okay, now this actually, technically this question is not correct, although if you happen to see this exact question again, the correct answer is A, okay? But this, to be technically correct, it should say the future value interest factor is always greater than 1.0 if the interest rate is positive. Okay? If, for example, you had a 0% interest rate, then it wouldn't be greater than 1. It will be equal to 1. If, for example, you had a negative interest rate, which up until the last 2 or 3 years, nobody really factored in negative interest rates, but we have been shown to have negative interest rates on some investments. So in that case, it would not be more than 1. But the best answer is always greater than 1. And by the way, the future value interest factor is this portion of the formula. So if we go to, okay, here we go. The future value is equal to the present value times 1 plus r raised to the nth power. This is the future value interest factor. It's the 1 plus r raised to the nth power. So for example, if we say it's 1 plus 0.01 raised to the first power, well, it's going to be 1.01, which is greater than 1, which is what the question answers. So with some of these questions, if you understand, if you go back to the formula sheet, you write down the formula and kind of work through a practice question, you can help answer some of the questions that are asked, okay? Just understanding the material. Okay, number 3, time value of money problem. Future value of $100 received today and deposited at 6% for 4 years is. Let me ask you first, what type of time value of money problem is this? Future value of an annuity, present value of an annuity, future value of a lump sum, present value of a lump sum, future value of a lump sum. Okay, so that's the first thing you need to identify when we're going through this. What type of problem am I working with? This is the future value of a lump sum. Now, you can do this a couple different ways. One is you could use the formula, which we just talked about, which if I can get my pen to work. All right, it's not a good time for this. What do I do? All right, we'll make it work, whatever we have to do. Okay, so in this example, when we're looking at this, first of all, if you understand time value of money, you know that the interest rate is 6%, you're investing it for 4 years, $100 is the present value, you can eliminate one answer immediately. Which answer can you eliminate without even working the problem? You can eliminate answer B immediately, because we just said if the interest rate is positive, the future value is going to be, future value interest factor is going to be greater than 1, so we know the future value is going to be more than $100. And as we look at this and we enter, oh, come on. All right, we'll do it the old-fashioned way. So if you enter your information, you need 3 inputs. You're going to solve for the 4th. And which 3 inputs do you need? You need a present value, you need an N, and you need an interest rate. Okay? So in this case, let's see if that helped. It did not help. All right, that's still not working. Okay, we'll just do it here. Okay, so the present value is 100. Man, that's really not working out right. Okay. N, well, I'll go into this. N equals 4 I/Y equals 6%. I didn't even know it had this capability. Okay. So these would be your inputs. You would solve for the future value, and you should come up with what answer? So you should come up with answer A. Now let me say something about this answer A and answer C. With this type of problem, typically what I try to do is I try to make the answers far enough apart so that you're not really confused if there's a rounding issue about, well, should it be 124, should it be 126? You know, there's typically going to be a much greater difference between the possible answers than that. Okay, that's just kind of an oddity. But the future value is 126. All right, so let's try this again. Okay. Okay, the next one, number 4, says if the interest rate is 0, the future value interest factor equals how much? If you look at the problem that we just worked, if you took the 1 plus r raised to the nth power, if you took, for example, 1 plus 0 raised to the first power, raised to the second power, raised to the 10th power, raised to the 100th power, is still going to equal what? 1.0. Okay? So the answer would be C for number 4. Number 5, the present value of $100 to be received 10 years from today, assuming an opportunity cost of 9% is, and again, if we look at number 5, a couple of these answers we can eliminate immediately. Which 2 are they? okay? We're looking for the present value of $100. So we know the present value, we're discounting that $100, so it's going to be less than 100. So we know that answer A and answer B are not possibilities. And in this case, we need three variables again. Oh, come on, man, work with me. Have any computer geniuses in here who can solve this problem? Anybody who wants to volunteer? Because I really don't want to use my mouse. Okay, here we go. All right, we're good to go. Okay, so with this one, we have a future value of 100. We need an N, we need an interest rate. So N is 10, the interest rate is 9%. We are looking for the present value. Now, for these types of problems, your calculator needs to be set on one payment per year. This is simply the present value of a lump sum or the present value of a single dollar amount. And so if you calculate this, and we bring up our financial calculator, again, I want to make sure that my payments per year are set on 1. So if I check that, and again, the payments per year right above the interest per year key. So now if I clear this out, and again, really important, once you get back to showing zeros on your calculator, press your second key and your clear time value of money, second, and clear work in the bottom left-hand corner. That's going to clear out any of your old inputs. And now we'll just enter our information. So 100 is our future value. 10 is our N, and 9 is the interest per year. And in this case, we want to compute the present value. So this is saying that $100 to be received 10 years from now, if we have an opportunity cost or a discount rate of 9%, it's going to equal $42.24. Did everybody come up with the right answer? Calculator working okay? Didn't come up with the right answer? What I did, I pressed the second key and then the I/Y. 1, enter. Now, second, clear time value money, second, work. Right. Okay, so these were the inputs. Did it work out? Okay. All right. So where am I here? All right. Okay, number 6, the amount of money that you would have that would have to be invested today at a given interest rate over a specified time period in order to equal a future amount is called what? Okay, now the wording of this is what throws a lot of people off. So that's why I want you to take a look at these. These questions are taken directly from the test bank that your test questions are chosen from. And that's why I provide these for you. One, to give you practice with it, but also just to let you see how the questions are written and kind of get used to some of the terminology. So in this case, for number 6, the answer is B, present value. Okay, so the amount that would have to be invested today, so this kind of gives it away, to accumulate a future amount. All right, so number 7. The present value of $200 to be received 10 years from today, assuming an opportunity cost of 10%, is how much? Okay, so we need 3 inputs again. And we have our 3. Again, what kind of problem is this? Present value of what? Of a lump sum, okay? So it's present value of a lump sum. So we've got 200, 10, and 10%. So in this case, our inputs, now again, I'm going to go back to clear. I'm going to press my second clear time value of money and second clear work after every single problem. And then my inputs are going to be 200 is my future value. 10 is in, and 10% is the I/Y, and I want to compute, in this case, the present value, which is $77.11. They rounded to $77 as the answer, which is there. So the answer would be D. Now, if we go through this and you're not getting the right answer or something, just raise your hand and stop me, okay? And we'll get the problem fixed. All right, number 8, the future value of a dollar blank as the interest rate increases, and blank the farther into the future an initial deposit is to be received. So if we're filling these in, you're kind of putting each one of these in. What you will find is answer C is the correct answer. The future value of a dollar increases as the interest rate increases, which makes sense. The future value is going to get larger as the interest rate that we use gets larger. And it increases the farther into the future an initial deposit is to be received. So that's saying the farther into the future from today that we actually receive the money or take out the investment, it's going to grow to a larger amount. So increases and increases. Number 9, the annual rate of return is variously referred to as, and I think I probably used all of these in class and examples, the discount rate, the opportunity cost, and the cost of capital. So the answer would be all of the above. An annuity with an infinite life is called what? Perpetuity. Okay, so a perpetual annuity, or an annuity that lasts forever. Number 11, the present value of a $20,000 perpetuity at a 7% discount rate is how much? So with this, you don't have to use your financial calculator. We just use the formula for the present value of perpetuity. And so if we go to that formula, the present value of a perpetuity is going to be the payment that you want to receive forever divided by the rate that you can earn, or in this case, the discount rate. So for this one, it was we wanted to receive $20,000. We could earn 7%. So in this case, 20,000 divided by 0.07 equals a present value of $285,714 and 29 cents if you want to be exactly correct. Now, keep in mind what we're doing here, and we've talked about this a couple of times in class. If we invest $285,714 today and we can earn 7% on that dollar amount, 7% interest on $285,714 is $20,000 per year. So all we're doing is we're just simply taking the interest that this deposit accumulates. We're never touching the principal, which is the $285,714, and so it's going to last forever as long as we can earn 7% interest or 7% return on our money. Okay, number 12. I think we might have had this on a quiz. Dan plans to fund his individual retirement account with the maximum contribution of $2,000 at the end of each year for the next 10 years. If Dan can earn 10% on his contributions, how much will he have at the end of the 10th year? Okay, so what kind of problem is this? Future value of what? You've only got two choices. An annuity. Okay. Now what kind of annuity? An ordinary annuity. Okay, that's exactly right. So in this case, we have our inputs, which are going to be a payment. So he's going to put in $2,000 per year. He's going to do this for 10 years, and the interest rate is 10%. And what is the future value? Now, for this one, you leave your calculator set to one payment per year because he's making an annual contribution. He's putting in $2,000 per year for 10 years, so he's putting in a total of $20,000. But the future value, when you calculate it, should be $31,874.85, which matches answer C for the question. 30. Is anybody else coming up with that? Is anybody coming up with 31,874? That's an odd difference. Okay, let's change it to, first of all, let me see this. Let's change it to 4 decimal places. Second, 4, enter. Try it now. Do what? Am I right? Okay. Yeah, I don't know what it was, mine just might have been cleared out completely. So again, I mean, that's why I keep harping on that, okay, over and over and over after every problem. Once you get back to zero, second clear time value of money, second clear work after every problem. Because if not, you're going to get some weird answers. Some of them may look pretty close, but they're going to be incorrect. Now, we're going to change this up just a little bit. Let's say you've got the same problem, but the question reads, he makes his deposit at the beginning of each year. Okay, so everything's the same. The only difference is he makes each $2,000 deposit at the beginning of each year. How much will he have at the end of year 10? So now we're changing this from an ordinary annuity to an annuity due. And we need to change our calculator to beginning of period payments. So in that case, for the second version of this, okay, we're going to change this to BGN. Everything else stays the same, and we want to know the future value. So let me go back over here. Okay, so for this one, and again, just for practice, we'll go through this. Now, to change the beginning of period payments, it's right above the payment keys. We're going to press the second key and the payment key. I'm currently set on end of period payment, but I'm going to use my set key, which is right above the enter key, to toggle back and forth between beginning and end of period payments. So if I press the second key and the enter key, now I'm set to beginning of period payments. If I press the clear button, you'll notice the small letters BGN at the top of the screen. That's to remind me I've changed the beginning of period payments, and now I can enter the information, which was $2,000 as my payment, 10 as my N, and 10 as the I/Y, and compute the future value. So what you'll notice is the future value should be larger than the first future value that we calculated. And somebody explain to me, why is the future value of this annuity due larger than the future value of the ordinary annuity? Because what? You're not making an extra payment because you're investing each payment one period earlier. So each payment, each deposit has an additional period of interest. So that's why the future value is larger for this one. All right, now, one other change to this problem. Let's say you're reading the problem, everything else is the same. He makes the deposits at the end of each period, but he deposits $2,000 per month at the end of each month for 10 years. So you see the word monthly in there, and the $2,000 per month means you need to change your calculator to 12 payments per year, but he makes the deposit at the end of each month. So that means you have to change back from beginning of period payments back to end of period payments. So for this one, it's going to look very similar. The only difference is we're going to change our calculator on this one to payments per year is 12. And we need to change back to the end of period payments. And so for this one, the payment is going to be $2,000 per month. N is going to be 10 times 12, which is 120 monthly deposits, and the interest per year stays at 10%, and we want to know the future value. Okay, so based on this, let me catch up with you here. Okay, so I'm going to change back. Change the 12 payments per year. So 2,000 is the payment. 120 is the N. 10 I/Y compute future value. Is that right? Yeah. All right, so that would be the future value. All right, so everybody come up with the right answers? No? For which one? The third one? Or both of them?
No, just the 40 pounds.
Just this one. All right, let's fix this. Probably. Okay, that's right. Try it now.
So just
Now, 2,000 will be your payment amount.
yeah, I did that myself. I don't know why.
Okay, now if you put that, yeah, you have to clear everything out. And it's going to be 120 because it's 10 times 12. Yeah. All right, now remember, if you're dealing with monthly payments, even though you change your calculator to 12 payments per year, you have to multiply the years times the months. Okay, so 10 times 12, which is 120. All right. Number 13, you've been offered a project paying $300 at the beginning of each year for the next 20 years. What is the maximum amount of money you would invest in this project if you expect 9% return on your investment? So what this is saying in simple terms is, how much would you be willing to pay today to receive $300 at the beginning of each year for the next 20 years if you require a 9% return on your money? So this is the present value of an annuity due. Okay? So for this one, we're going to, again, we've got 3 inputs. We have our payment, but you need to change the beginning of period payments first before you enter this information. So the payment's 300, N is 20, interest per year is 9, and again, we need to change the beginning of period payments, and we're looking for, in this case, the present value. How much would we pay today? So to calculate this, with our financial calculator, now I'm going to change the beginning of period payments. Then I'm going to go through the clear process once I'm back to zeros. Then I'll put in my 300 as my payment. 20 is my in, and 9 interest per year. Compute the present value. And that's not right. Aha. Okay. Even I forget. It's easy to forget if you don't check these things. Okay, I'll still set on 12 payments per year. All right, so let's do this again really quickly. 300 is the payment. 20 in 9 I/Y compute present value. Okay. So what this tells us is you would pay $2,985.03 today to receive $300 at the beginning of each year for the next 20 years if you required a 9% return on your investment. Did everybody get that answer correct? After you change from 12 payments per year to 1 payment per year? Okay. Okay, this is the present value of a mixed stream of cash flow. So the present value of $1,000 received at the end of year 1, $1,200 at the end of year 2, and $1,300 at the end of year 3, assuming an opportunity cost of 7% is. Okay, so this is a present value problem. Now with this, you can work it a couple of different ways. What we have here is our mixed stream. So if we not exactly correct, but it's close enough. So this is time period 0, 1, second to right, 2, 3, and 1,000, 1,200, and 1,300. And what we're doing is we're taking each of these cash flows back to time period 0. So we're taking them back the appropriate time period. All right, and we're discounting these at what was it say, 7%. So we're going to take the 1,000 back 1 time period. We're taking the 1,200 back 2 time periods, and the 1,300 back 3 time periods to time period 0. And then we could add them all up. So we could work them one at a time if we wanted to. We could also use the cash flow register on our calculator. So we go over to the CF key. And if we do that, okay, so I'm going to go here. I'm going to press the CF key. Well, actually, I'm going to clear this out, okay, this beginning. So second payment, second, enter. And then just out of habit, I'm moving through the clear process. So now my CF key. Now you'll notice I've got some information in there from an old problem, so I'm going to press my second and the clear work button, just the second and clear work button to clear out the old cash flows. And I can enter the cash flows as they occur. Now I only have cash flows at time period 1, 2, and 3. This is cash flow at time period 0. I don't have a cash flow at time period 0, so I'm simply going to press my down arrow key 1 time to go to cash flow number 1. And I'm going to enter here my 1,000. And again, it tells you at the top, you have to press your enter key to lock it in. Now I'm going to press my down arrow key again. It's going to ask for the frequency. How many times in a row does the $1,000 occur? The default is 1. That's correct. So we're just going to down arrow past it to cash flow 2, which is 1,200. Press the enter key to lock it in. Press the down arrow key. The frequency is 1, which is correct. So we'll press the down arrow key again, and the last cash flow is 1,300. And then press the enter key to lock it in. Now if you press your down arrow key, you'll see the frequency, which is 1, which is correct. And then if you keep pressing it, you're going to go to time period 4, and then you're going to go back to where you started from. So it's always good, once you've got your cash flows entered, go back and take a look to make sure you remember to press the enter key to lock them in. So I've got $1,000 at time period 1, $1,200 at time period 2, and $1,300 at time period 3, and I don't have any other cash flows in my calculator. Okay, so that's where we want to be. The next step after this is to press the net present value key, the NPV key, directly to the right of the cash flow button. So if I press the NPV key, I'm going to enter my discount rate, which in this case is 7%. So 7. Press the enter key to lock it in. Press your down arrow key 1 time, and it tells you at the top of the screen, press your compute key in the top left-hand corner to come up with the solution. And the solution here is $3,043, which matches answer B. So did everybody come up with the correct answer for the cash flow register?
What was the last step? Did you answer compute what?
Once you get to, are you showing NPV?
Yeah.
Press the compute key. Top. Get the right answer. All right. Okay, so present value of a mixed stream of cash flows. Okay, number 15 actually is not a good question. It says the rate of interest actually paid or earned, also called the APR, is called, I should actually take this part out, okay? If this part were not there, then what would be the answer? A, the effective rate of interest, okay? The APR is the annual percentage rate. It takes into account, if you get a loan, it takes into account things like fees that you might pay on your loan and that type of thing. And so it's what you're paying, but it doesn't take into account compounding. So that's technically not a correct question, okay? It should just say the rate of interest actually paid or earned is what? The effective rate of interest. Okay, loan calculation question. Betty borrows $50,000, 10% annually compounded interest to be repaid in 4 equal annual payments. The actual end of year loan payment is, so for this one, again, we need 3 inputs. We need our, so let me go here first. So for this one, we need our present value, which is how much we're borrowing, 50,000. We're going to pay back in 4 annual payments, so we just have, we leave our calculator set to 1 payment per year. And the interest rate, seems like we have a lot of 10% interest rates in this, but 10%. And we're looking for the payment. So if you go through this, the payment should equal, and I'll work through it on my calculator, but it should equal $15,773.54 per year. And so in working through this, $50,000 is the present value. 4 N 10 I/Y compute payment, and you come up with $15,773.54 per year for 4 years. Will pay off the loan and the interest. Okay, so that is the end of practice questions for chapter 5. Okay, let's run through some of the other ones really quickly, starting with chapter 8. Number 17, if a person's required return does not change when risk increases, that person is said to be what? So they're risk indifferent, okay? Number 18, if a person's required return decreases for an increase in risk, that person is said to be what, and this should actually be A, B, C, and D. Okay, if their return actually goes down for an increase in risk, they would be considered risk seeking. Okay. All right, number 19. Blank is a chance of loss or the variability of returns associated with a given asset. Risk. It's simply the chance of earning something other than what you thought you were going to earn. So it could be more or less. A lot of times we just think of risk in terms of earning less than we thought we were going to earn, but it should actually be earning more than we were going to earn. Number 20. This is a percentage return calculation. Last year, Mike bought 100 shares of Dallas Corporation common stock for $53 per share. During the year, he received dividends of $1.45 per share. The stock is currently selling for $60 per share. What rate of return did Mike earn over the year? Okay, so we have our information here. And the formula that we're going to use is going to be the end of year dollar amount minus the beginning of year dollar amount plus any cash flow received during the year divided by the beginning dollar amount. So to do that, using the numbers that were given for the return, our return is going to be equal to the 60 end of year amount minus the beginning plus the dividend divided by the beginning amount. And so that's going to be 845 divided by 53, which equals 0.1594 or 15.94%. So we earned almost 16% on his investment during the year. And that matches answer D. You will, yeah, you'll be given the percentage return formula. All right. Number 21, the blank measures the dispersion around the expected value. Standard deviation. Number 22, the blank is a measure of relative dispersion used in comparing the risk of assets with different expected returns. And that's going to be A, the coefficient of variation. We said the standard deviation is useful for comparing the risk of assets with the same expected returns. The coefficient of variation is useful for comparing the risk of assets with different expected returns. The standard deviation is a real measure. The coefficient of variation is a relative measure. All right, number 23. Since for a given increase in risk, most managers require an increase in return, they are what? Now the answer is D, risk averse. They want to be paid for taking additional risk. Now I said they want to be paid. It doesn't mean they're going to make additional return. It's just that they expect to earn an additional return. All right, the expected value, standard deviation, and coefficient of variation for asset A is what? Now let me ask you this. Does anyone need me to work through this problem for you? All right, I was afraid you were going to say that. Okay. Okay, so this is a expected return, standard deviation, coefficient of variation problem. So let's knock this out. I'll take advantage of the lines here. Okay, so the expected return, and we're going to call this R bar. And this is just going to be equal to the probability times the return. So if we follow the information here, that's 0.25 times 0.05 plus 0.55 times a return of 10% plus 0.20 times a return of 0.13. And I'm assuming after you work through that and looking at the answer that I have circled, you're going to come up with and expected return. Once you do this math, do this math, do this math, and then add them all together, you're going to come up with 0.0935. And somebody can check that if you want to do the math on it, but I think that's the expected return. So we expect to earn on this portfolio 9.35%. All right, now once we have the expected return, then we need to calculate the standard deviation. So to calculate the standard deviation for asset A, our formula is going to be, we're going to take the return minus the expected return squared times the probability of that return occurring, and we're going to do that for each of the possible probabilities, so 3 separate times. So for this, we're going to take the return of 0.05 minus the expected return of 0.0935 squared times the probability, which is 0.25. Plus, and we're just going to do this for each one of them. So the next one is going to be the return of 10% minus 0.0935 squared times the return, times the probability of 0.55 plus, we'll keep on going down here, the return of 0.13 minus the expected return 0.0935 squared times the probability of 0.20. I left that out here too. And remember, all of this is under the radical, okay, the entire formula. Now, again, it's going to be really important to work through these in the correct order. So we're going to take the 0.05 minus 0.0935 squared times 0.25, whatever that comes to, okay? Then we're going to take the 0.1 minus 0.0935 squared times 0.55. My guess is that's going to be a really, really small number, probably 0, although I'm not positive, depending on how you have your calculator set up. And then the last one, 13 minus the expected return squared times the probability. Once you've added all three of these together, done the math, added them together, you take the square root of it, and it should be 0.0276. .76% as a standard deviation. And then the last one, the coefficient of variation for asset A, is simply going to be the standard deviation of 2.76 divided by the expected return of 9.35. And you can do it either way you want to. If you want to put 0.0276 and keep with these, with the decimal format we've been using, that's fine. You're going to get the same thing. And so it's going to equal 0.3. So answer for 24, answer D should be the correct answer. So does that help? And that's actually the only one on my piece of paper here, the only one that I didn't work out ahead of time, so that's why I didn't go ahead and do all the math on it. I'll just let you do the calculations. Okay, so 24. Let's go ahead and move through some of these pretty quickly. Oh my gosh, what I turn on now. All right, 25. The blank portfolio maximizes return for a given level of risk or minimizes risk for a given level of return. What do we call that? called it the efficient portfolio. Okay, that's the group of assets that you put together that if you're going to take a certain level of risk, you want to receive the highest return from that group of assets, or you want to reduce your risk by as much as possible if you have a set return that you want to receive from that portfolio. So that is the efficient portfolio. Number 26, I'm not going to read through all of that, but I can tell you the answer is D. Okay, so perfectly positively correlated has a correlation coefficient of +1, perfectly negatively correlated coefficient of -1. So the answer is D for number 26. Number 27, combining negatively correlated assets have the same expected return results in a portfolio with blank level of expected return and blank level of risk. And we actually looked at a table that showed us this in chapter 8. So the answer should be C. Now, to be technically correct, it should be combining, well, that'll work. That'll work the way it's written. So the same level of return, expected return, and a lower level of risk. Number 28. Okay, so we've got a lot of information here. We've got a $50,000 portfolio, 3 assets, R, J, and K, $25,000 invested in R with an expected return of 12%, $10,000 invested in asset J with a expected return of 18%, and $15,000 invested in K with an expected return of 8%. The expected annual return of the portfolio is how much? Well, we can work that out. So the first thing we need to do, since they're not given to us, is we need to calculate the percentage weights. And so we've got the weight of asset R, and the formula is going to be the dollar value of the asset divided by the value of the portfolio. So in this case, that's going to be 25,000 divided by 50,000, which is 50% or 0.50. The weight for the second asset, which was asset J, I guess, I don't know, one of those. Asset J is 10,000 divided by 50,000 equals 0.20. And the last one, which is asset K, there was $15,000. And so that's going to be 0.3 or 30%. Now these need to add to 1.0 or 100%. So if we take a look at this, 50 plus 20 plus 30, that does equal our 100%. Now the next step, once we have our weights, is we simply need to take, for our formula for the return of a portfolio, it's going to be the weight of each asset times the expected return of each asset. So if we take the weight of asset R, which is 0.50, 50%, times the expected return of 12%, plus the weight of asset J, which is 20%, times the expected return of 18%, plus the weight of asset K, which is 30%, times the expected return of 18%. And if we work through all this again, work through these separately, add them together, you should come up with 0.12 or a 12% expected return. Okay, so does everybody see where these numbers are coming from here, where I'm getting the weights and the returns? And if you see something like this on the test, you can work through it with no problem. Yes? Okay. You don't have to speak, just a head nod's okay. I'll take that at this point, okay. All right, let's get the rest of these knocked out. So that was 28. This table actually goes to the problem on the next page. It says the correlation of returns between asset A and B can be characterized as, so if we go back and look at A and B, notice that over time as asset A is increasing, asset B is decreasing. So we would say that there is a B perfect negative correlation between these assets. All right, 30, systematic risk is also referred to as non-diversifiable. Apparently it doesn't like the way I spelled that. Non-diversifiable risk. Answer C. Number 31, the purpose of adding an asset with a negative or low positive beta is to what? And this will be adding it to your portfolio, and that would be to reduce risk. 32, pretty straightforward. The beta of the market is always how much? Always 1.0. And then number 33, this is a capital asset pricing model problem. Asset P has a beta of 0.9. The risk-free rate is 8%. The return on the market is 14%. The required return of the asset is how much? So we've got our information. We can enter it into our capital asset pricing model, which is the expected return of an asset is equal to the risk-free rate plus the beta of that stock multiplied by the risk-free rate minus the return of the market. So if we, wait a minute, that's wrong. There you go, there you go. Need to change it up. Okay, so this is the return of the market minus the risk-free rate. So if we plug this information in based on our problem, that is going to be the risk-free rate of 8 plus the beta of 0.9. The return of the market is 14 minus the risk-free rate of 8. So if we work through this, that's 8 plus 0.9 times 6, which is 8, plus 5.4, which gives us a 13.4% required return for this particular stock, which matches answer A. And that completes all of our practice problems. So, are there any questions about anything before I send you out into the world to study and prepare for your finance test on Thursday? You can, they're on Canvas. Yeah, there's chapter 8 and chapter 5 and chapter 8 forms. All right, everybody, have a great day. Study hard. If you need to see me in the office tomorrow, shoot me an email. Make sure I'm there, and we will discuss whatever we need to talk about.